It was fun to see you guys in Texas the last time. Please ask questions. So one thing I wanted to jump in is, Charles did a really good explanation into what we're doing in terms of application control. Just a little bit expand on that. So we are doing this for all the applications that Charles mentioned on top of a virtual infrastructure. We're actually doing the exact same thing for those applications and other applications on top that are running in containers as well. So for example, here I've got a VM that's running a couple of containers, and I can actually drill down into what applications are running in that container as well, and provide the same application control functionality with the understanding of the whole stack from applications to containers to a public or a private cloud infrastructure, all the way down the stack. And actually the funny thing is, in this case, maybe I could show this through the inventory view. So here I've got a Java application that's running in a container. The container is running on a VM. The VM is using resources, in this case, from a private cloud, ESX host and a data store and a resource pool. So I could drill even further into the infrastructure. And it happens to be VMTurbo running in a container. So I'm actually using VMTurbo to control ourselves. We actually have the way I did this is I deployed it in a container, a persistence container that runs our historical reports, a platform container that runs our basically our core economic scheduling engine, and a presentation container that runs our user interface, our web front end. So you could kind of deploy VMTurbo and control it with VMTurbo at the same time, which I think is kind of cool. There's a couple of other things that I wanted to mention and expand on, both in the context of applications running in VMs or running in containers, that the complexity of this multidimensional data center that we want to control continues to expand. We have been, for the past couple of years, focusing on how do we assure the performance of these applications in terms of compute and storage resources, and in terms of raw network bandwidth. What we found is that as you grow, especially as you start to use hybrid cloud, the combination for public and your private cloud, how much traffic goes between any two application endpoints becomes more and more important. So what we've done is that we basically extended our universe and introduced the ability to feed network flow information into VMTurbo. So VMTurbo makes decisions by understanding which application is talking to which application, how much traffic is going on between them, and we're also tapping into the underlay network, the actual physical infrastructure that delivers the connectivity, to understand how close those applications are to each other. And based on the combination of this demand for communication on the overlay between applications and the supply of the actual underlay network infrastructure, how do we best meet that demand? How do we minimize latency and at the same time use our infrastructure efficiently, but deploy and run our applications in a smart way? Because it's actually a really complicated trade-off. All of these things change very dynamically, but network communication matrices really change in a very dynamic way. And VMs and containers running applications that talk frequently with each other can end up very far away from each other, which then introduce high latency. But if you try to move them closer to each other, you might end up with a compute or a storage bottleneck. If you force them to be on the same host, they may not be able to both get their compute and storage resources. So it becomes one of the most, I think, complex trade-off. How do you find this desired state between network latency and compute and storage performance bottleneck prevention continuously in your environment? So what we do is we basically take advantage of NetFlow or SFlow instrumentation to understand what applications, what VMs, what containers are talking to each other, and we tap into network switch vendor APIs like the Arista API to understand your switch to host connectivity, and based on that are able to understand what your network traffic is and how it goes across your network. We basically introduced two concepts. One is a concept of a vPod as a group of applications that communicate frequently with each other and generate a lot of traffic talking to each other, and the concept of a dPod that is infrastructure that's closely connected, say on the same top of the rack switch. And what we do is, in addition to finding the best place to run, to deploy, and you run your applications in a VM or in a container, we also have now the ability to control these vPods, a group of applications. So if you are running a group of apps and you have the ability to run them on a public and on a private cloud, then you don't end up moving half of the VMs to your public cloud, pushing the traffic back to your private cloud. We've got the ability to identify that these applications all talk to each other, and if you need to burst out, you could move the whole vPod out from a dPod, which either could be your private infrastructure. We actually map public cloud zones into dPods as well, so that you either stay within a zone or you move into your public cloud or into a different zone, the whole group of applications that are talking with each other.
So that'll move back and forth. It'll move them for you between public and private cloud, or it'll make the recommendation to do that. Does it give a higher cost to, for instance, the public cloud?
Yes.
There's resources of it? Okay.
Absolutely. So it's a couple of things. So one is a number of really good question that we are driving these actions based on both the business constraints, the SLAs, and the performance constraints. But in addition to pricing those constraints, we are also pricing the actions. And the price of the action of moving between a public and a private cloud is higher. So you need to have a significant gain to move into a public cloud. Cloning is relatively cheaper, but I don't know if we talked about it in the previous slide. What we described in terms of our application control capability not only applies to vertically scaling applications, but also to horizontally scaling applications. And the same SLA definition that we described earlier apply to a horizontally scaling application. Instead of driving a resize or reconfiguration of the infrastructure, we'll drive a clone of those application instances, containers and VMs included. Now it's important that if we clone a container, we end up either cloning the container that stays closer to the other bodies that it's talking to, stays within the same dPod as part of the same vPod, or if we want to clone the whole thing, we'll clone the whole thing out into a public cloud, which might be cheaper than moving the full state of a stateful application that is vertically scaling otherwise. But we do differentiate on the cost, so good point.
You also mentioned that you're using NetFlow. Will it take into account anything like VXLAN or any encapsulation that's being done there?
Absolutely. So basically, what we do is in most of our deployments, we take the flow information, either NetFlow or RESTflow information, from the software switches, from the overlay. So they actually, and you have to do that to be able to really understand the application traffic. I mentioned the two sources of data: the data that feeds this flow information as a demand, and the data that comes from the underlay network infrastructure. They come from two different places, so they don't have to come from the same switch. I can have a OpenV switch or a VMware VDS feeding me flow information. I can have an Arista switch that has no clue about what the VXLAN traffic is. It's just sending the tunnel traffic, provide me with the physical infrastructure layout, how my hosts are connected to my switches, and we actually take care of mapping that into this supply chain and are controlling the infrastructure.
Thanks.
Right. I guess I described some of this already. Some demo stuff. So I don't know if I'm not generating a whole lot of traffic, but what I have here is So the only thing that you had to do in VMTurbo is to point our software to a flow collector, and everything else we take care of automatically. Or if you point it to one of your CloudVision API endpoints in Arista switch, we discovered the whole Arista network from there. Arista is one of the things that we announced last quarter. And from there, we basically discovered these pods automatically. This happens to be a group of applications. In this case, it's a group of VMs that are talking to each other. And we discovered the physical infrastructure, a group of hosts and data stores that are closely connected with each other. What we do is we actually differentiate between traffic that is local to a host, that is local to a pod, so it usually stays within the same rack, versus traffic that goes across your core network or traffic that goes across your cross data center, public and private cloud. And we actually end up pricing those flows differently. So if two applications are talking to each other, even if they are generating the same amount of traffic, if they want to be apart from each other, they have to pay a lot more money. Whereas generating the same traffic, being either in the same rack and increasingly more so even being in the same host, will become so much cheaper for them. But at the same time, they're not only shopping for this flow information, for this flow traffic, but they're also shopping for compute and storage. So as they come closer together, that compute and storage may become more expensive. So basically, by the nature, each one of these applications will find the best trade-off between how close they can get to each other without causing a compute and a storage bottleneck.